Why not? They're your videos. So the starting question here, a little bit kind of an oddity here because you're not like, what am I supposed to do here? Well, they're trying to help you out by giving you the numerical, the data in a table. Okay. The table, usually X is the first column and Y is the second column. All right, so we're going to label these points on the graph first. You typically go from the numerical data to the graph. All right, and
Yeah.
we've got to label the X and the Y. And to do that, we kind of look here, okay, like 20, 25, 30. That means maybe we can go up by 5 here ish, maybe. We got to be careful here on the Y. It goes 40, 34, 28. So is there enough room here? 5, 10, 15, 20, 25, 30, 35, 40. There is. So I would recommend going by 5 here. And I wish they gave you more room, but you can use 5 on both the X and the Y. So the first ordered pair is 20 on 40. So you just count that out, 5, 10, 15, 20. 40 is up there. 25, 34. So this one you're kind of estimating where it is. It's like there. And then 30 comma 28 is a little bit lower right in there, maybe. Okay. Is that clear?
Yeah.
All right. So the next one typically would be like an equation. We're not given great data that works out perfectly. So I don't know how much, like how exact you're supposed to be here. Do you know if this was just kind of a estimation or if you had to be really precise with it?
It doesn't have to be super precise now.
Okay, so here's what we can say. We can say that um, as as distance increases, we'll do the verbal one first. It's not very precise. As distance increases, basically as you get bigger, 20, 35, 30, the gas, the gas decreases. And so this is like one of those, what's called an inverse, where as one goes up, the other goes down. As one goes down, the other goes up. These are inverse
Yeah.
relationships. We see these all the time. Now, algebraically, it's like y equals, and then this is where it's like, what's the slope? Um, we can say minus x plus, and then it's like, well, where would this go up and hit? That's where it's kind of hard to estimate, but looked like it would hit probably up at like 60 maybe. Just kind of estimating, eyeballing where this would go up and hit. We can't see it, something like that. And so the goal here for the instructor is to get you to see that the information in a function can be represented table, graph, equation, and in words.
Okay.
Let me know when you get this down, and we'll move on to number 2.
All right, I got it down.
All right, so next problem here, actually, let me scratch this for the moment. Evaluating functions. Are you allowed to use a calculator in the class?
Yeah.
Okay, that's good news. So one of the things that is really good to do when you're writing a function is to rewrite it with the variable in parentheses.
Hmm.
If you do this, you will avoid making catastrophic errors in your calculations. Okay.
Yeah.
Because when you do g of -2, when you calculate g of -2, that goes now in the parentheses.
Okay.
And you avoid these awful sign errors that, depending on your instructor, could be like on a multiple choice, they'll give you all the possible wrong answers that are reasonable to get here. So the reason I asked if you had a calculator is if you enter this into the calculator exactly the way it's written, you will get the correct answer. If you have to do it by hand, well, you could make a lot of mistakes. Um, just to be clear, these are negatives, not subtraction operators in your
Yeah.
TI 8384. Do you want to calculate this for us, please?
The
The whole thing.
oh, okay. Um, G parentheses -2 equals -4 -6 +1.
Big. So it sounds like you're doing it by hand, which is fine. I want the final answer.
Uh, G parentheses -square equals -9.
Yes, very good. Okay. Any questions, thoughts on that before we proceed?
Uh, no.
Okay. All right. Part B. Part B here is to do G of X plus 2. This one is even more awkward than the negative. You're putting X plus 2 in for X. So it's negative parentheses X plus 2 squared plus 3 parentheses X plus 2 plus 1, like that. Let me know when you get that down. The next line here is be easy to make some mistakes. We'll go through it together.
Okay.
All right, so the next thing here is to remember that when you have something squared, that means you're writing it out twice.
Yeah.
And it's so easy to just do the wrong thing. And you're in pre-calculus now, and it's like, okay, maybe in algebra 1 you get a pass, in algebra 2, they it's not as bad, but it's really bad now. Like you really got to make sure you don't, like, oh yeah, it's X squared plus, no, it's not. So you have to FOIL this first. I'd like you to do that for me, please. And then we'll deal with the negative. Okay. I'd like you to give me the FOIL on this.
X squared plus 4x plus 4.
Yep. And notice I'm putting it in parentheses because this negative is distributed to everything.
Yeah.
And you can either do it, now or later on. You then distribute that 3. That's okay so far? Yes.
Okay.
Tristan, are you good up here? Because the next thing is to combine like terms.
Okay.
So why don't you do that and let me know your final answer here, please.
Um, Wait, is the -4? Wait, is the -4 adding to 3x?
Okay, so let me circle the like terms, negative 4x and positive
Negative
3x.
3x. Yeah.
So see how the operator goes with it. And
Yeah.
then negative 4 plus 6 plus 1. Those all go together. Nothing goes with the negative x squared. There's no other x squareds.
Uh, negative x squared minus x plus 3.
You got it.
Yeah.
Yep, good. Really good. Right. Do you have a graphing calculator?
Yeah.
Okay. You'll need it for the next problem for sure.
Okay.
All right, so let me know when you got your graphing calculator out.
All right, I got it.
All right, so I've got on my screen, you should be seeing a virtual TI-83. If you got an 84, it'll be mostly the same. If it doesn't
Yeah,
look the same,
I got an 84 plus CE.
great. This is close enough. So first thing is to graph what they're asking you to graph, you've got to go to y equals. You hit the y equals button, and
Uh-huh.
we're going to enter that equation that's there. I mentioned this before. You got to use the negative operator. And then you don't use t. T isn't a variable,
Yeah.
an option there,
Right.
caret 3, and so on. You probably know how to do this based on what you've been saying. So go ahead and enter
Oh,
this.
hold up. Accidentally was doing okay.
Now,
Bruh.
if you already had something in there, you could clear it out as well.
Yeah. It's just my exponents being weird. But okay.
All right. So I kind of always make this comment. They give you this calculator to use, but they never tell you how to use it. Um, if you hit the graph button, and depending on what you have previously graphed, what it does here, and this doesn't help. Um, like this is the equivalent of like going to Google Maps or something, or going to your maps, and like you're not even in the right like state. It's like, well, that doesn't really help. So if you don't see
Yeah.
anything, or if your windows change, you still don't see anything, like that's totally normal. So what they don't tell you to do is there's this thing called zoom, and if you go down to zoom fit, what this tries to do, that's 0. Make sure you see that there. What it tries to do is fit a window. Now, is it perfect? No. Does it work better than, just graphing it? Yeah. Like you just hit enter here. I don't know what'll happen, but we'll see. We'll get a better window, hopefully.
I got an error syntax.
Oh boy. Okay, so let's go back to the y equals. Make sure that in front of the 10 is a negative operator. In front of the 20 is a subtraction operator, the
Okay.
one off to the right. Calculators are dumb. They don't do anything you don't tell them. So you gotta just give it what it expects there. And then go to zoom and go down to zoom fit 0 there
Uh-huh.
and hit enter.
Yeah, it's check all arguments entered. Uh,
All right. Well, so this is where
Maybe it's my format. I don't really know.
so Here's what I can't do. I can't see what's on your calculator, but what I can tell you to do, and this is up to you, you can do the following. You can hit second mem and you can reset your calculator here, number 7, if you want. Now, if you have games on there or if you have programs on there, you don't want to do this. But if you do reset your calculator, it should get you back to where you can just do what I've been doing. Um, otherwise,
Second,
otherwise, you got to figure out what's going on here with that. I'm gonna step aside for 30 seconds. I got to replace some batteries. My mouse or my be less efficient. I'll be right back. Maybe you can figure that out in the meantime. Be right back with you.
all right,
Clearing it.
yeah.
Okay. On thing.
All right, how are you doing on this?
Re-answering it right now. On a on. Okay. All right, I re-answered it.
So hit graph and see if it worked.
Okay.
You won't see
It doesn't
this.
have like the trace on it, but it has like the graph, I guess.
Okay, so go to zoom and then go down to zoom fit, which is 0, that's 9, or you can go up
Yeah. Enter.
that. Yep, enter. All right.
Okay.
Oh, good. It's
You should
working.
you should see something like
Yeah, I
what's on
got
my
it
screen.
now.
Okay, now this is again, it's like not the it's better, but it's not the right view. This is where you go to window, click
Oh
on
yeah,
window
yeah,
here.
window.
And we're gonna now try to answer this. Now, you really need to go back to the, and I don't know if you have this in front of you, the question to know kind of how to answer this. So it says that P, which is X, in the question is the number of years since 1994. So year 0, which should be your min, is 1994. 2003 is year 10 roughly. So 0 to 10 is good. The X scale is the increment. It's
Uh,
the increment on the x-axis. So 1 is fine because you're going from 0 to 10. That means you're going up by 1. Your y min is, let's go to 0. The reason you might go to 0 is that, well, it's talking about money, millions of dollars. So 0 is a good place to go. Y max, probably too high. Um, let's go to 40,000 for right now. So 40,123. And then your scale, you don't want 1. It's the increment. So typically you divide by 10, maybe as a idea. So make it 4,000. That means every increment on your Y is going to be up by 10.
oh, I do 40,000 for max. Okay.
Yep. And then your scale, make it 4,000. Let me know when you get all these entered. Make sure they're the same here,
Yeah.
and we'll go back and hit the graph button whenever you're ready.
Okay. They hit the graph.
Graph. Yeah, hit graph. And hopefully you see something like this.
Yeah.
All right. Now, we don't have a great shape to it. Let me see what you're trying to find. So I feel like we could maybe tighten in on this a little bit because we don't really get a nice shape. Although I really like starting at 0. But you can see our midway point here is around 20,000. So maybe we want to go from like 10,000 to 30,000 to see a little shape. So let's go back to the window. And I want you to change the min to now 10,000, 10, and let's go 30,000 here. And this time, let's increment by 5,000. Kind of nice numbers to increment by.
Okay,
And then whenever you got that down, we'll hit graph.
alright.
So this is what's called an iterative approach. It's like you try something and then yeah, this is okay. I mean, it's not great. It's probably good enough though for what your instructor wants. Uh, so let me grab some snip and we'll go back to the other screen. And we'll also talk about how to do some of the other ones using your calculator. Let me go back to window. All right, so I'm going to go back to the other screen. We may go back and forth here. So the X min means the like literally the x zero, which is it's the lower bound on the x. The x max of 10 is this last dot here, and then y min is 10,000, and then y max is 30,000. That's this last dot up here, like that. So that's when it says friendly window, graph with a friendly window, it means that well, you have this here. Now we maybe should have gone out a little further. I'm looking ahead here. Um, we'll do that in a moment. But
Okay.
go ahead and get this down in your window, and then we'll talk about part B. How to do part B on the calculator.
Okay.
Okay, so it says, what does E of 5 mean? Find it. So P equals 5, and we know that P equals 0 is year 1994. So T equals 5 is 5 years later. That's year 1999. So the meaning of E of 5 means in 1999, it's the amount of athletic equipment sold. And I'm just reading what's in here. Like I'm not doing anything sophisticated. It's the amount of
Yeah.
athletic equipment sold in millions of dollars. I think sometimes there's this like perception there's something really amazing going on. It's not. Um, okay. Now to find it, we're going to go back to the calculator. So whenever you're ready, I'm going to go back to that screen to show you how to do this. Let me know when you're ready for that.
Alright.
So we go back, new share, calculator. All right, so I'm going to go back to the graph. Okay, here's our graph. Yay. Make sure you get yours look similar. And then I'm going to hit the second button here, second, and then calc. So whenever I say second, and your teacher probably does this as well, and they say the word, they're referring to the yellow word. It's not second trace, it's second calc. It's a way to get two buttons out of one
Yeah.
on your calculator. This was before, touch screens, whatever. So second calc. And then you want to calculate the value. So you want to hit enter for 1. And you want to put x equals 5. Let me know when you get caught up here. And when you put 5 in, then you hit enter.
I am.
And then you should see that right there, 20300. And that's what you're writing down for your answer. But it
X
is,
equals 5.
yeah.
Okay. 5.
Let's do, I guess it doesn't actually graph each
Okay,
one.
where is the Y? What button
What's
do I
that?
press Y?
Say that one more time.
Which button do I press to enter the Y?
You are writing down the Y, 20,300.
Yeah, what button do I press to,
Do you have this on your screen or not? That.
not the Y?
Did you hit enter after, is it say X equals 5 and then hit enter?
Yeah. Okay.
Let me know if you have something different.
Oh, okay, there you go, never mind.
Okay. Part C says to approximate the maximum sales. And this is where we've got kind of an issue. Like you can kind of see the graph goes up. And then it looks like it might come down, but we're not going out far enough. So we're going to change our window. So I want you to go back to window and let's go out instead of 10 on the X max, let's go out to 20. Do you typically like double or half when you're making changes? So when you get this, hit the graph button. Let me know when you're up here because I don't want to jump ahead if you don't have this. It's important that you do it.
Oops. Graph. Yeah. And 20. All
I'm going to
right.
change to the rest. I will hit graph. So you should see something that goes up and then see how it comes down and crashes. So the thing that's maybe not clear that we should change in your window there is we probably should have made our X max 20 instead of 10. So you're going to make that change on your answer sheet. That's probably a better thing to do. So the maximum sales you agree is right somewhere in there where my cursor is, roughly.
Yeah.
So to actually calculate it, you go back and you hit second calc again
Mhm.
and see where it says maximum,
Yeah.
or you want to choose that and hit enter. Now this is not the maximum, just where it put there. So let me know when you see left bound on your screen.
Yep.
Okay, so you're going to use the directional pad here, the D-pad, and you're going to go left of the maximum. Like, and the whole question is, like, well, how far left? Well, left of it. So somewhere around here, this is left of it. That's what it means by left bound, left of the Mac. Hit enter.
At which
And
point?
then,
Oh, yeah.
what's that? It
No.
doesn't matter where, roughly it can be anywhere. Now, right bound means to go right of the maximum. So go somewhere right of it,
Uh-huh.
ish. Yours doesn't have to be exactly like mine, just somewhere right of it. And then hit enter. Now, what you should see or see these little arrows, they're trying to tell you that to look for the max between those 2 points. And then it says guess. You can guess right where you were. You don't have to go to where the maximum is, just guess right where you are and hit enter. And you should see this when you're done.
Okay. Yeah.
Right, so I'm going to go back to the other screen now. And the maximum sales is the Y value. It's 22029. That's in millions of dollars.
Okay.
Do part B. What does the y-intercept mean? So if we go back to the graph, I guess this is the only graph I got here that's any good. Um, the y-intercept is right there. That's the y-intercept. And it's when you're finding E of 0, which means that T equals 0, which is year 1994. So in your class, they want you to be able to write a sentence to interpret. So like understand, like, do you understand? Okay. So let's see if we understand here. In year 1994, it's the amount of athletic equipment sold. That's the y-intercept. It's the base year. They call it the base year, the starting year,
Yeah.
stuff like that. All right. Any thoughts or questions or follow-up to that before we move on to 4A?
No, not right now.
Okay. And if you ever have questions about your calculator, please let me know in the lesson, because they don't give you enough instruction in the classroom on this stuff.
Yeah.
All right. So 4A, do you drink coffee?
Now,
Okay. So let's just pretend you buy a large pizza from, where do you like to get pizza from?
Pizza Hut.
Well, Pizza Hut's great. So what happens to the temperature of the pizza over time? And time is down here, and this is temperature. Like, when you get the pizza from Pizza, it's just come out of the oven, what do
Yeah.
you notice about the temperature?
Well, it's probably gonna drop over time.
Right. It's really hot to start. It's really hot. Like, you probably don't eat it. Or if
Yeah.
you do, you burn your mouth. And then as time goes on, right? Like, we've all had a cold slice of pizza. Depending on your
Yeah.
mood, could be a good thing, right? Um, so what happens to the temperature? Like you need to do something that connects something in here. And there's a lot of right answers. There's not. Um, could you put something down here, or what you think happens?
Like write it.
No, a graph it, like
Probably
something
start
here.
off at the top of the Y axis and uh yeah.
Now here, this is also an acceptable answer. But I do something like this. Sure,
Yeah.
that's okay. Does it actually get to 0 degrees? I mean, depends if you put it
Yeah.
in the fridge or not. There's
Yeah.
a lot of all right. Let's do I guess we'll do B next. Have you been on a Ferris wheel before?
Yeah.
Okay. So let's draw a picture of a Ferris wheel, and let's
Okay.
pretend that you are right here.
Yeah.
Okay. You are some distance above the ground, right? Like, maybe it's like 2 feet, but usually you step up, right? So you start and you're like right there. You're some little bit above the ground.
Okay.
And then the ride starts and you get to this position up here.
Okay.
So sometime later you're up here.
Yeah.
And then what happens?
Uh you go back down.
You go back down. And then what happens? You go back,
Uh,
okay? And then you go back down.
yeah.
Now, I don't remember if you did sine, cosine, tangent graphs in your previous class. I have no idea. I couldn't tell you. But that is what's going on here. It's a sinusoidal wave. It's dropping down, dropping up, like that.
Okay.
And I don't know how you're supposed to know that. Your teacher may give you some grace here and say, all right, it could be straight lines, but it's really not. It's actually kind of this rotation. It's a little curvature to it. Let me know when you get that down.
Yep.
So you got to be careful here that you don't graph the physical situation. You graph
Yeah.
what it, in this case, time and height. You can draw the physical situation, you should, but you don't need to graph it. That's not what you're graphing. So here we go. Another question here. Swing at the park. Okay. So like, here's the swing, there's the seat that you're in. Okay. Panes come down, right? And then maybe you start here, right?
Uh-huh.
And you push him and he goes up. Okay. Then
Yeah.
what happens to him?
Yeah.
Gravity pulls him back down. Does he stop here though?
No, he goes forward.
He goes the other direction. Then he goes back. So think about his height. So, again, kind of slightly off the ground to start, right?
Yeah.
And then he goes to the right. So he goes up some height up, comes back down, some height up, comes back down, some height up, comes back down. So notice it looks really similar to the previous one. I don't know why that got lost. And it goes on until you get tired of pushing your cousin.
Okay. All right.
So whenever you're ready, if you want to transition to that other page.
All right.
So here we got 1.3 factoring. You did the one right next to it, correct? Let me snip that in. This one's exactly the one that you did not do is exactly the same. This is UCF, greatest common factor. And the greatest common factor can be either a number or a letter or both. So in this one you did on the right here, I don't know if you did it by yourself or with the teacher, but you can see that 8 goes into both 8 and 48. X goes into x squared and x. Can you attempt to do the same thing here? Like, is there a number that goes into 6 and 60?
6.
Okay. And notice there's only one variable, so you're not going to be able to factor anything out there. And this is they call it divide and slide, I guess. You're dividing 6v by 6 and 60 by 6. What goes in parentheses here?
Uh,
What is
the
the net result?
the V um Yeah, plus what's 10? I don't know.
Yep. You need a calculator. I'm not anti-calculator. I don't know why. It's like making someone I don't know. It's like we have cell phones, like you don't make people run down the street. You just call. Okay, this third one here is totally different than the one we just did. I call this A equals 1 factoring because the value of A in front of x squared is 1. What you're looking for here are two numbers that multiply to 8 but add to 9. Multiply to 8 but add to 9. So multiplies to that last number, adds to the middle. Could you attempt to come up with those, please?
Did multiplication. Uh, no, 8 and 1.
Okay. So it becomes x plus 8, x plus 1. And the order doesn't matter. If you like x plus 1, x plus 8.
Yeah. Is that a 1 in front of the x squared?
It's just me writing a 1 to indicate this is what's called A equals 1 factoring. That's just the type. And the reason I did that is to distinguish it from what we're doing next, which is A not equal to 1 factoring in the next problem here. So let me put that up here on screen. So I call this A not equal to 1 factoring. It's also sometimes referred to as grouping because it does involve grouping. Based on what I saw in a previous problem here, it looked like you might use the guess and check approach. Do you know what you had like in the 6x squared?
My new teacher, she doesn't really like that method, but
Yeah, it's like it worked when you're a good guesser. It doesn't work when you make bad choices.
yeah.
So I don't know. You like the correct way to do this is take the 6 and the
Yeah.
-2 and multiply those together, and you get -12. And you're looking for two numbers that multiply to -12, but now add a -1, that middle number there, -1. And that's where this gets, this is where you're still guessing to some degree. You're like, all right, well, what multiplies to -12 adds to -1? So take a minute, see if you can come up with that. I'll jump in if you're not able to figure them out.
-2 and 4. Oh, yeah. No.
Those do not multiply to 12. So for example, I'll go through some of the
Yeah.
possibilities. 1
Yeah.
and -12, -1 and 12, 2 and
Oh,
-6, -2 and 6, 3 and -4, -3 and 4. Do any of those, because these all multiply to -12. And one of them could add to -1, and that's what we're looking for.
okay.
Do any of these add to -1? Three
Uh,
and -4. So what we do now is we break apart this -1x into 6x squared plus 3x minus 4x minus 2 equals 0. So you're splitting apart that -1x into the 3x and the -4x. And then you do GCF factoring on the first two, which ends up being 3x. And just because we're running out of time here, I'm going to kind of finish out this problem for you. So the next thing here, once you figure out the greatest common factor, you can divide it out. You then immediately write what's in parentheses off to the right here. And then you figure out, well, what goes in the middle here such that when you multiply in, you get back to the previous line. It ends up being -2. And you know, if you don't understand this, or this doesn't, it seems more complicated. It is at start, but then when you do a few, you realize, okay, this actually is better because it always works. Then each of these has a 2x plus 1. So it becomes 3x minus 2 because you factored out. And then to finish this, you set each of these equal to 0. I know we're going quickly here. Make sure we get this all done. And then you subtract 1, divide by 2. So x equals -1/2. Add 2, 3x equals 2, divide by 3, 2/3 like that. All right, so go ahead and get this down, or if you can't, don't think you can in time, you can get it from the notes later. Definitely would use some more practice on factoring if you have time this week.
Yeah.
But I know, like most students, time is limited. You're always sort of competing for that.
Yeah.
All right, I'm gonna go ahead and stop the recording here.